Welcome to homework.
So we are looking to write a formation reaction for calcium chloride here. And if we think about it, we have to have two molecules of chlorine. And chlorine is a diatomic molecule, so it will always be found with two of them in its gaseous state. And now we just need 1 mole of calcium. Calcium is typically a solid at standard conditions. So this formation reaction is just 1 mole of calcium solid and 1 mole of diatomic chlorine gas will form the calcium chloride. All right, so next we are looking at the formation here of sodium bicarbonate, which is NaHCO3. And now we have to think of the base elements and how they typically are in standard conditions that will form this. So we'll first start with sodium. We know sodium is a metal, and in standard conditions will be seen as a solid. So we have solid sodium here. So now we have that on the left side. Now if we look at hydrogen, hydrogen is a diatomic gas here in its standard state. Now we only have one hydrogen molecule on the right, and we have two on the left, so we know we're going to have to use a coefficient of 1/2 to make sure that this is balanced. Next we have carbon. Carbon in its standard state is solid, so we have that there. And then finally we have to find oxygen. Oxygen is also diatomic in its standard state as a gas with two molecules of oxygen bound together, but we need 3 on the right side, so we need a coefficient. And in order to get 3, we must multiply by the coefficient 3/2. So now we have the formation of sodium bicarbonate with 1 mole of sodium solid, 1/2 mole of diatomic hydrogen gas, 1 mole of carbon solid, and 3/2 moles of diatomic oxygen gas. So next we are going to look at the formation of carbon and 4 chlorines, so carbon tetrachloride here. And we know from before that carbon typically in its standard state will be a solid, so we have 1 mole of the solid carbon, and then we have chlorine in its standard state is a diatomic gas, so here we have Cl2. We have 4 on the right side, however, so we know we need the coefficient of 2 to get this as a balanced equation. And this is the formation equation for carbon tetrachloride. And now we're going to look at the formation of nitric acid, HNO3. We know typically hydrogen is a diatomic gas. And now we have 2 hydrogens on the left, but only 1 on the right. So we need a coefficient of 1/2 here to balance that. And next we have nitrogen, which again is a diatomic gas. So again, we only have 1 nitrogen on the right, so we need to use a coefficient of 1/2 on the left to balance that. And then finally we have our O2, which is also a diatomic gas. It will always come in pairs when it is at standard conditions. And in order to balance the left and right side, we have to multiply by a coefficient of 3/2 to balance. So just to simplify, here are the 4 reactions. We have the formation of calcium dichloride. We have the formation of sodium bicarbonate, the formation of carbon tetrachloride, and the formation of nitric acid here, and this is all done at standard conditions. And these are all the reactants on the left here, how they're found naturally.